Okay, so good morning, everyone. My name is Abhishek, and I am a part of group B42DA001 Data Dynamos. And today I am here in front of you to describe about my project that is solar power plant analysis. So before that, I just want to explain you about the data set. So this is the Kaggle website, and we have the four data set in front of us. So the first data is plant one generation data. The second is plant one weather sensor data, and the same is for plant two and plant two weather sensor data. So out of these four for our project, we have taken plant one data set only because of time constraints. And at the same time, we also want to have in-depth analysis on plant one. So this is about the selection of data. Now I will explain you what are the different columns available in plant one data sets. So there is a column like date and time there that specifies the date and time for each observation for every 15 minutes of interval. After that, we are having plant ID. This is same for plant one. And then we have source key. So there are different source keys here that represents the different inverter IDs. So at the later point of time, we will calculate it how many unique inverters are there. And then we have columns like DC power, AC power. So this tells us about the amount of DC power generated by the inverter in this 15-minute interval. Same is with the AC power. So what is the difference between DC power and AC power? So it is just a minute difference that whatever you can say solar panel generated is DC power, and after that whatever the inverter converted into usable power, it is AC power. So it is the difference. Then we have a daily yield. It tells us about the sum of power generated on that day till that point in time, and the total yield will tell us that the inverter generated till that point in time. So it is the total uh, power generated, and this is the power generated on that particular day. So I think I have discussed a lot about my data set. Now we will go to our Streamlit app that we have made. Okay. So now I will walk you through the Streamlit app that we have made using Streamlit tool. So one of the most important highlight of our app is showcasing the important metrics in front of you. So as you can see that there are different metrics like total DC power, total AC power, unique plants we have, average ambient temperature, module average temperature, and total irradiation per meter square of solar panel. So from this metrics, what user can expect. So from looking at these metrics, it helps quickly grasp more important insights rather than going through the large data set. A user can just simply look into it and he gets some more important insight. Apart from that, it also helps in decision making. These metrics make decision making faster and more efficient. So this is about the metrics. Then we will go to the sidebar. So we also integrated the sidebar by using st.sidebar. So user can click on it and we'll see the different options available here. And then we also integrated date selection because there are data of 34 days. So as per user, this date can be selected. So for example, here the user want to select the date 15 to 22, then he can select this range and now the data will toggle as per the date selected here. So this is about the data selection. Apart from that, we are having the data exploration option and KPI selection, and each of them we have provided checkbox option so that at that particular point in space, if user want a particular KPI to explore, then he or she would have the option. So for example, if the user want to see the total power generated on those particular days, and he can just simply click on it, and now the data will come at front of him like this. Uh, that will tell you about the total power generated per day on those selected days. So it is about the checkboxes that we have integrated by using Streamlit app. Okay. So after then, I will walk you through the data exploration and visualization part. So we have different options like user can see the correlation heat map, like what is the relationship between different features available in the dataset. So for example, here we can clearly see that module temperature has a very positive uh, correlation with irradiation, and also the irradiation has the positive correlation with the module temperature. So with the increase in irradiation, module temperature also increases. So user can use it for their as per their requirement. So if I talk about the KPI exploration, then this I have already explained you. So we will explore this KPI. So this KPI will tell you the average hourly power output. So here red is shown you the DC power, and this purple color will show you the AC power. As the DC power generated by panels are high, so this graph is high, and the amount of AC power, sorry, DC power converted into AC power is less. So so you can see this like that. This graph is showing like that. Okay. So now we will go to the next KPI. So user can also see peak power generation hours. So these are the hours of the day, 24 hours. So you can clearly see that at 12, you can say PM, the peak power generation is there. So by just looking at that, if power plant owner want to repair or get maintained their solar panels, so accordingly he can make decisions like if he want to get maintenance of their panels, then he should prefer those hours, as if he do maintenance during these hours, then their loss of power generation will be less. So from that, this is concluded. Now we will explore the efficiency analysis. In efficiency analysis, you can clearly see that different days has a different efficiency analysis, but more or less they are same. So it tells you about that what is the efficiency of converting DC power into AC power. So nearly 9% is the efficiency rate of solar panels. Okay, so now we will explore about the power loss. Power loss is telling you that how much is the power loss. For example, here the difference between the AC power and the DC power is nearly 4,000. So this is different for different uh, days. So yes, now we will explore to the energy loss due to temperature. So here you can see what is the loss of energy due to temperature. So these are also different for different days. And we can also see that there are 2 days where energy loss is very high. So this is a very useful information for the user. Okay. Apart from that, now we will explore the impact of temperature on power generation. As in solar power generation, the output is very important, and the temperature is a very important aspect for solar power generation. So we will see the what is the relationship between the ambient temperature and the power output. So as we know that as the ambient temperature increases, as the sun rises, sun is at the head, there is a positive correlation between both of them. Similarly, we can also see the correlation between power output and module temperature. So here also we can see that as the power module temperature increases, power output is also increases. So this is about the KPI selections. Then apart from that, if the user want to explore about data exploration, then we can also see that. So for example, here she can see the what is the DC and AC power trends throughout the days. So like that, he can see that, and he can see that the direct power is more and the easy power is more for the different time stems. Okay, and finally, he can also explore show DC power and daily heat per day. So now it is loading. I will tell you about this also. It is also a very important aspect of our project, which we will going to see in just a few minutes. Okay, so as the relationship is here, so here DC and daily power heat. So here, if you can see that you can see the different gaps that are coming here. So these are the maintenance period, or you can say that you can check that what is the reason for this. If this is because of maintenance, then it is okay. And if there is no maintenance on that particular point of time on particular day, then the power plant owner can check whether is there any problem with the panels or it is because of maintenance. So from this, the user can gain this much. Okay, so I think I have explained you all about my project.